Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 34, I chat with Bob Farinelli, CTO of Elan Home Systems, about distributing audio and video throughout the home. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, episode 34, All Around the House. This episode of Home Theater Geeks is brought to you by Squarespace.com, the fast and easy way to publish a high-quality website or blog. For a free trial and 10% off your new account, use the offer code HTG. Hey there, Scott Wilkinson here with UltimateAVMag.com and HomeTheaterMag.com. Before we get started today, I wanted to quickly mention that we're running a sweepstakes on UltimateAVMag.com. The prize is the complete Lord of the Rings trilogy on Blu-ray, plus a special package of collectibles from that series. So all you have to do is go to ultimateavmag.com, register if you don't already have an account, and post a comment on the blog that announces the sweepstakes. And good luck to you on that. This week's guest geek is Bob Farinelli, CTO and president of Elan Home Systems, which is a company that specializes in whole house audio and video distribution. And I thought it was particularly appropriate to talk with him today, since tomorrow both of us and a lot of other people leave for the CEDIA trade show, the Custom Electronics Design and Installation Association, which I'm sure is Bob's big show of the year. Hey, Bob, welcome to the show.
Hey, thanks. Thanks for having me.
Thanks so much for taking some time out in your day before leaving for CEDIA. I'm sure you got a lot of prep to do, as I do, but I'm looking forward to talking to you about whole house audio in preparation for the show. Those who are watching the live video stream at live.twit.tv or in the chat room at irc.twit.tv can pose questions for Bob as we go, and I will pass on as many as I can. So, Bob, let's start with a little bit of your history. I understand that as a child you took apart your family's old Zenith TV to get the radio out. Is that the story?
Well, that's kind of how I got my start. The TV, finally bit the dust, and so I drugged the console down into the basement. There's a really nice little sunken radio console, then there's a TV in the center, and then there's a record player on the side. So I wanted to take the radio out and put it in a wood case, and then hook up the speakers to it. So, the radio in the back of the picture tube, the chassis down below, the record player, there's a whole bunch of wires, interconnecting all these things. So I said, well, I'll cut the red one and save the green one. And so I try and take it all apart. I'm like, okay, I finally get it, taken apart, and then I plug it in and it goes, oh. So that was, I didn't get electrocuted, so that's the good news.
That's good news.
I was just fascinated by audio video since, an early age, and, so that was my first hands-on experience, so to speak.
Literally hands-on.
That's right.
And then later, I understand you were working at Hughes.
Right, yeah.
And
when I graduated from college, I took a job at Hughes Aircraft Company to start with as a design engineer. And designing test equipment for that's the shaggy hairdo. I was a young fella back then.
Yeah,
25 years old. I thought I knew everything about everything. So that's a test station.
Remember, this is the
designed.
70s.
Yeah, 75.
Okay,
75.
very good.
That's right.
And so you're working on missile guidance systems.
Yes. And it was kind of interesting, but I had been doing TV repair when I was in college. I just loved the audio-video side of things, and so I wanted to get out of that. And I actually ended up at Mattel working on video games back in the Intellivision days.
Oh, wow.
And that was fun, get to play video games and get paid for it. I always thought that was kind of cool.
That's very cool.
And I worked on satellite receiver products and satellite dishes back in the 10-foot dish days when they first started to make that available to consumers.
Now, I understand you did some wind tests during during those days. I think we have a photo of that, of a few of your compatriots testing. I assume that with a 10-foot satellite dish, and I do remember those days, you had to be pretty concerned about wind because that would knock those things over in a hurry.
Right. They had to be, wind tested to 120 miles an hour. So we had, we got some wind generators from, this is, I'm the guy, the skinniest guy there with the blue on. So these are radial aircraft engines mounted in this cowling, and we would blow this, 80-mile-an-hour wind from that, and then we hook up to the fire hydrant to get the water to go, and that would simulate the 120-mile-an-hour wind. So we wanted to make sure the structural integrity of the satellite mount system was good, and so that was kind of a fun couple of days of
it sounds like it.
Get load on.
So let's turn now to your more recent work, or at least the topic of distributed audio and video throughout the home. Audio came first, I'm sure. Why don't you give us a brief rundown of how that came about in the world of consumer electronics?
Well, there's a really interesting short story on just the history of how wiring ended up in the house. And it started with a 2-wire bell wire for the telephones back in the 1880s. And, so the first consumer product, electronic product, was a telephone handset. In 1920, thereabouts, AM radio became available. I have a sample here of one that's very interesting. It's a Tesla Czechoslovakian produced radio.
Wow, look at that.
So I'm a collector of antique radios, so I have some very cool ones. This one is very cool because each radio station is a city in Europe. Oslo, Warsaw, Minsk, a whole bunch of places. So every city had its own radio station, right? And
wow,
so
and that was marked on the dial.
That's marked on a dial. That's right. So it's very cool. This is how the real consumer electronics started back in the 20s with the AM shortwave radio handsets. And so in about 1940, along came FM radio and stereophonic music reproduction, and then you ended up with stereo speakers, whether it be in a console or freestanding speakers. So that happened in the 40s. So by 1950, the residential wiring, you had electrical wires run to an outlet in each room, 2-conductor bell wire to the kitchen phone usually. There was a twin lead that came down to the TV set. Oh, yeah, there was a TV invented somewhere in there. And the entertainment console, the speakers that I took apart. So that's kind of the modern home of the 1950s. You got a couple of runs here and there of a few pieces of wire for those few devices. So once they launched the satellites in the 50s, we ended up getting cable TV in the 70s, and space race and all. So we had coax cable drop into the house, and it ran from the pole to the TV set-top converter on top of your TV set. So, but only in that one place, because if you wanted an extra outlet, you may remember that, they would charge you for an extra outlet. Same with the phone company. They charge you for phones. Actually, they own the phones. So 2 things happened, which most people don't realize, that changed the way residential wiring took place. One was the 1984 breakup of AT&T. All of a sudden, you could go buy telephone handsets that were all shapes and sizes and hook them up to your own wiring in your home that you owned. And then in 1992, the FCC passed the Cable Deregulation Act, and all of a sudden now people had multiple coax drops into each bedroom or wherever they wanted it, with splitters and amplifiers and such. So all of a sudden, due to government deregulation, houses have house-wide wiring networks. So before that,
and yet they have all kinds of different types of wiring throughout the house. There's power line, there's coax, there's phone line. How do these all get integrated together?
Well,
or do they?
Yes, structured wiring, which was prevalent in commercial building structures. It was always a structuring wiring center. back in 90, when I started at Square D Company, part of the Elan startup group, we created a residential structured wiring product that had coax, dual runs of coax, dual runs of Cat5 from each room back to the central location where it was then distributed and could be easily reconfigured. So that was kind of the beginning of structured wiring category for residential products, and I was happy to be a part of that process back in 1990 with Square D.
Gotcha. And meanwhile, since then, Elan has been in the invention business essentially over the last 20 years. I think you have a couple of examples to show us of that. Yes.
I've been very fortunate to be involved in consumer electronics development here at Elan for the last 20 years. The first I'd like to show is that we got a little block diagram which we sent. Do you have that handy by chance?
Pretty sure it's called the first audio amp. And I think
audio distribution.
John, there it is. Okay, good.
Okay, kind of hard to see.
There it is.
There we go.
A little better.
So, I drew this back in 1990. It basically shows, some audio inputs, a paging input from a telephone handset, doorbell control. There's a couple of power amplifiers, some control logic. So this is just a hand-drawn sketch of the first audio distribution amp with integration of paging and door chime into a home-wide system. So now, instead of just a stereo system or multiple stereo systems, we had it's a single-source whole-house music distribution system with paging interruption and with door chime interruption. The funny story: when the first ones started to ship, the door chime trigger from a doorbell button was a little bit sensitive to lightning strikes, like in the neighborhood. I mean, you hate it when the flash and the boom happens at the same time, but what would happen when it would trigger, of course, it would be in the middle of the night, the lightning would strike down in the neighborhood, and the person's doorbell would ring immediately. So it's like Freddy Krueger at the front door, so it wasn't funny to them.
No, I'm sure it wasn't.
It taught us an early lesson that when you take equipment that you connect to a whole house-wide network of wiring, you've got to really be careful and protected from surges and, EMP pulses from lightning strikes and stuff like that. So that was our first lesson, and, we've tried to, really do a good job of making sure that things are robust and reliable in these house-wide networks. Mm-hmm. So that first audio product used volume controls for in-room volume adjustments. So we've got a bunch of patents that we built upon that first product with, starting first with a volume control, which we didn't patent, of course, but we picked those up. But we started to make changes, and so I'll show you just a brief kind of evolution of the volume control from the Elan perspective. So first sample here, this is just your basic volume control. Got two transformers and a rotary switch on it. Nothing too complicated, nothing too fancy here. The next thing we did, because, when you turn the volume controls down in the room, you don't hear a page or a door chime when it rings.
Yep. And
so what we did was we put a little relay on the volume control. I don't know if you can see that or not.
No,
so that when and we sent a control signal to it, so when the page or door chime took place, then the relay would click to some jumpers that would override the knob setting, and then you get your page and door chime. So that's a patent that Elan got early on. So we go from a rotary knob, straightforward thing, to one with override. We also have a slider kind of a switch that's a little more appealing, Decora type of product. And then we said, okay, well, let's just take that and go a little bit further. So who wants slider switches and knobs? We have an up-down press button, and then to be able to use that, we've got a bank of relays here that select the taps from the transformer instead of a knob on a switch or slider switch. So, and then we also have a built-in IR receiver. So this is sort of an evolutionary process for us over some number of years to take volume control technology and turn it into, cooler stuff. So the last piece here, I'm going to hold this up. This is 6 sets of volume controls in a box, and got a patent application on this. So what there's speaker selector switches, speaker boxes. Those are the highest volume multi-room audio systems that have ever sold. Hundreds of thousands of those types of systems have sold. And usually they've got a big resistor inside, so you don't short out the amplifier when you put all 4 channels on. And
you don't want that.
That's right. And it takes away the power from the loads, and it does protect the amps. So when we put all these volume controls in one box, we've got an IR remote. We also have an RF remote controllable speaker selector box. And when they're all in the box at the same time with one processor under control, we can do some intelligent things like if one is up and the others are off, you can put all the power to that one set of speakers. As you start to turn others up, you can change the impedance match settings so that the amp continues to stay in protection, but there's maximum power delivered to the load. So that's what you get when you have one processor in charge of the whole group of things. So this is just sort of an example of how over the last 20 years we've taken simple technology and turned it into more complex to create solutions for homeowners, you know, for multi-room distribution.
Well, I want to ask you a lot more about multi-room and whole house distribution in just a second. But before I get to that, I'd like to thank our sponsor for this episode, Squarespace.com, which is an easy-to-use user interface for creating and managing a website or blog. It's optimized for both beginners and CSS experts, so anybody out there can certainly use it, with hundreds of design templates to choose from, and you can customize any of the designs to fit your needs. This all-inclusive service includes several modules to build your website, including blog modules with import-export support for WordPress, Blogger, movable type, and Typepad. And exporting, of course, means data portability, and you can create forums, photo galleries, forms to collect email addresses and other information, Google Maps, and more. Website tracking and built-in search engine optimizer permission are another couple of good features there. You can get permission access and cloud architecture for speed and site stability, and innovative drag-and-drop Ajax interfaces. Man, this thing's got everything. Use Squarespace for all your website needs. Build it, host it, and manage it. For a free trial, go to squarespace.com/HTG. No credit card needed just to try it out. And so if you decide to purchase, you can get 10% off when you enter the offer code HTG. So please do. Go check it out if you're thinking at all about building your own website or blog. This would be a great way to do it. So make sure you let them know that you heard it on Home Theater Geeks. That's squarespace.com/HTG. Okay, so back to Bob Farinelli of Elan Home Systems. And I want to start thinking about the here and now. What do people need to think about in terms of whole house audio-video distribution during, say, if they're building a house and they're in the middle of initial construction, they want to have audio and video distributed around. What are the sort of key elements that they sort of need to be thinking about in order to prepare for that?
Well, for new home construction, we still recommend, you know, dual runs of RG6 coax, dual runs of Cat6 these days, not Cat5, to, you know, multiple locations in bedrooms, you know, in living rooms and stuff like that, kitchens. There's, you know, some people think that, you know, fiber should be pulled to all these locations as well. With the challenges of HDMI bandwidths, you know, that's not a bad idea. I think if you're ready to, if you really want to wire for the future, then having some fiber pulls would be good, or at least some Smurf tubes where you can snake them from floor to floor, you know, later and be able to, you know, drop them down.
I'm sorry, Smurf tubes?
I'm sorry. They're just, you know, empty tubes that go floor to floor that, you know, they're kind of flexible. So that if you
sort of conduits.
Conduit, yes. Plastic, kind of flexible plastic conduit that gives you a chance to, you know, be able to run wires if you need to down the road. So that's kind of a trick that custom installers have these days. But also things like Cat6 to, you know, wireless access points that you might place up in the attic is a good idea. Some, you know, Cat6 and coax to where you might have a satellite dish mounted, where on the roof or, you know, underside.
Why Cat6 instead of Cat5?
Well, Cat6 has a higher bandwidth capability.
Of
I
course.
mean, if you're going to pull, you know, a conductor,
Ethernet.
You know, Ethernet, then you might as well pull Cat6. You know,
Sure.
I don't think it's really very much more expensive these days than Cat5. So, so now, you know, if you're into multi-room, you know, you have to decide if you want in-wall speakers or freestanding speakers. If you're going to have in-wall speakers, you'll want to run some speaker wire, 18.2 or 4, back to maybe where a location is for a stereo system, or back to a location on the wall near the door entry if you're going to have a keypad-based system, and then run 18.4 or 16.4 from you know, a central location where your stereo gear may be to that keypad location, along with, again, a Cat 6. So that gives you control. It gives you audio. Your audio can loop through that junction box and go to the speakers directly, or if you're going to put in a less expensive, you know, volume control-based system, then you just snip them and put the control in there. So you have some options either way for that.
Now about speaker level, I just wanted to ask you one thing about speakers. You have these in-ceiling speakers, say, or in-wall speakers. Does the gauge of the wire that you're running to them matter? I mean, if it's a long distance, do you want thicker cable or not?
Yes, you do. You know, in-wall architectural speakers just don't have that much power handling capacity. So 18 gauge wire is fine for, you know, runs up to 100 feet. Custom installers are probably ready to throw tomatoes at me because they'll always want to pull 16.4, which is nothing wrong with that, of course, but it costs more money. So if you've got long runs, yes, 16.4, shorter runs, 18.4. There is a big difference in the cost of the cable. So, you know, I've pulled 18.4 throughout my house, and when you only got 30 to 50 watts of music for background music and for architectural speakers, that's more than sufficient.
And what about another question I've always wondered about is distributing audio by line level and having an amplifier local in each zone or each room versus distributing that audio at speaker level and having the amplifier at what I think we call the head end, you know, in the central location, and sending speaker level out to the remote zones. Is there any advantage or disadvantage to either of those approaches?
Well, if you send line level or digital, you know, SPDIF to the room, line level really needs to be a balanced differential pair for, you know, left and right, so that it's got noise immunity. Or you can send a SPDIF over coax, for example. Video switchers are really great SPDIF switchers, by the way, because the bandwidths are compatible. But so the centralized amplifier, the advantage of it is that you've got one chassis, one power supply, you know, and everything is right there. The distributed amplifiers, you'll have more hardware in general if you've got 6 or 7 in-room amplifiers. But there are things that, you know, keypad-based amplifiers, there's analog, there's also a digital version, one that we created at Elan called Digi5 that has, you know, a SPDIF digital. It's an all-digital system all the way to the power amplifier, which is right at the keypad, and then it's converted to speaker-level audio right at the keypad and then brought to the speakers. So
with relatively
you know,
short cables.
Well, we can go, you know, 150 feet because we're using 4 of the 8 conductors for power and ground. So we got some other patent things going on with that as well.
I meant, you know, what I meant was relatively short speaker cables from the keypad to the local in-wall speakers.
Correct. You are correct. Usually the keypad and the speakers are in the same location. Yes.
Right. Yeah, exactly. So there's an advantage there. We got a question in the chat room that's very similar to what we've been talking about. Is the audio quality compromised by sending speaker level long distances?
Well, generally the amplifiers and the speakers are pretty low impedance, right? So you're not going to get a lot of noise ingress from vacuum cleaners or other kinds of things where you'd be able to pick them up. Usually the biggest challenge for multi-channel amplifier manufacturers is to minimize the crosstalk between amplifier channels. So in some respects, yes, it's not as good if you've got an amplifier that where one room is really loud and the other one's off, but they share a common chassis. Sometimes you get bleed over within the chassis itself from the loud channels to the quiet channels. You know, the quiet channels being out in the granny's house or, you know, out in the pool house. Right. And so you've got to be really careful about how you design, you know, a distributed audio amplifier to minimize crosstalk. But certainly with the low impedances at speaker level audio is involved, you will get any pickup of noise. It's certainly better than sending line level analog.
Mm-hmm. And I would guess that sending digital might be the best solution, as you were talking about earlier. If you have a little digital amp in your keypad or elsewhere in the room, send it SPDIF, and you don't get any problems, any of those problems at all, and the amplification is local. That may be the best solution of all. Would you agree?
Well, you can only get so much power out of an amplifier built into a keypad.
True enough. I understand.
But there is no question that the digital audio transmission all the way to that amplifier chip is unaltered and is perfect. Mm-hmm. So if you had digital audio delivered to the room and then you had a beefier in-room amplifier, you would have a better audio experience. A 30-watt keypad sounds pretty good, but if you've got inefficient, bookshelf speakers, or you like to listen to it really loud, or a real heavy bass, you're going to probably want more than 30 watts per channel. So that's where you make the compromises.
Yeah, yeah. Now, getting back to another thing you mentioned earlier, long HDMI runs. Clearly, we know that HDMI, you can't really run at a really long distance without some sort of booster. So there are other solutions to getting that HDMI video and audio, I guess, at this point, over long distances. What are some of those?
Well, there are some Cat5 extenders that are available. They can't go from 50 feet to 300 feet without repeaters. There's also HDMI over coax, usually a dual run of coax, and that's good for 100, 150 feet. But if you want to go 500 to 1,000 feet, there are fiber optic solutions that will not only transport the HDMI signal, but also provide serial control, signal transport, or IR control. And companies like Geffen make those kinds of products that are fiber optic based.
Mm-hmm. And so Elan will use some of those third-party products to get that HDMI over a very long distance?
Right. That's right.
Mm-hmm. Mm-hmm.
Elan's customers, right?
Yeah, exactly. What about distributing audio and video over IP, over the local network? I understand you're introducing something at CEDIA along these lines.
We have a new line called G that has cloud content that we'll be able to take from a network connection, and then provide Pandora and Rhapsody. Here in the next month or two, we'll have that online, and so it's a foundation or a building block for distributed audio over IP with cloud content, as well as NAS drive and content aggregation feature sets. So it's very exciting, very exciting thing we're launching here.
Great. Is there did I understand that you have a little demo you can show us on that?
Well, we have a couple of user interfaces that I can show you. You have a slide that shows our keypads, for example.
Okay. So if our engineer can pull that up, it's called Interfaces. We should be able to see that, and that's a part of this G system you're talking about?
That's right.
Mm-hmm. There we go.
So this really kind of shows a couple of different flavors of products. This is the first on the left, uses an OLED display
nice.
and a thin film overlay. So the buttons are not mappable, but the center area where the feedback is shows source information and source feedback, like transport control and the stations, tuner presets and things like that. Mm-hmm. So that's a low cost user interface. That also you can look at lighting and climate and security on that as well. This is the Elan historical user interface. This is what it has looked like up until the release of the one that is on the right. So Elan's been in the touchscreen business since not 2000 or something like that, 2001. Mm-hmm. And so we've sold a lot of those touchscreens, but that's not an IP-based touchscreen. If you slide on over now to the right, you'll see that this is the new G touchscreen. You can see it's a lot richer,
wow,
a lot more detailed. So this is sort of a progression from the old ones to the new one. This will give you cover art. It's got hard buttons on the side for lighting and volume and mute control, things like that.
Is that an OLED screen as well?
No, this is a quarter VGA display and the other one, the one in the center, is an LCD display. So we go from OLED to LCD to quarter VGA type screens.
Isn't that odd that the OLED, which is sort of the the display of the future, as it has often been called, was like your first one, your oldest one?
Yeah, that was shown in a sequence of size as opposed to events or releases. So OLEDs have only been available for 3 or 4 years.
Right, that's what I thought.
And so the LCD display has been available for quite a longer time. So before we had OLED displays, that's a good segue here for, this is Elan's first keypad, right? Very simple, 6 buttons, got a few LEDs on it, IR receiver, like that. So you could, like that, transport control, you could, make the CD player play. And then, so it kind of migrated into the next generation. I have another little prop here. This is a foam core of our new remote control we're showing at the show. This is the same stuff you stick flowers into, right, at the florist. and then this over here, this is the actual finished product. And so you can see we actually kind of got the bass down pretty good. And so this is another interface for the G that has the same kind of graphics, the same kind of control function, but in a handheld version.
This was my next question. You segued beautifully, because keypads are great, but they're mounted in the wall. And if you're sitting watching TV or listening to music, you don't want to get up and go to the keypad in order to, go to the next track or, change channels on your TV. So handheld remotes still have a place in whole house distribution, and you clearly have one there. With this new G system, I'm assuming that you can also do it with other universal remotes, or maybe you have an iPad or iPod Touch or iPhone app, a control app for your systems.
Right, we do have an iPhone, and soon to be released an upgraded iPad app to control these systems as well. So there's a raging debate about keypads on the wall, remote controls, stuff between the couch cushions. Right, when you walk in the room, you want to be able to turn stuff on and sit down and enjoy. So keypads on the wall give you that ability to do so, including macroizing, turning on the lights and stuff like that. Also, if you just want to listen to music. You don't want to have to turn the TV set on to select, information or music channels. So there's some good benefits. Keypads don't tend to disappear or get stepped on either, like remotes do. They don't lose their batteries, Right. So it's more, I'd say, more expensive to have a keypad system. Remote controls are becoming more prevalent. There's a lot of folks out there making really cool, nice remote controls. We're entering in that marketplace because we feel it's essential for our products to have our own remote instead of someone else's control all the things in our system. So,
so it's good to have both. It sounds like what you're saying.
Yes.
Yeah. Before we leave IP, we had a question from the chat room, which is there anything better than RG6 coax? Oh, that's not IP. That's coax. My mistake. Well, in terms of coax distribution, anything better than RG6 coax, or is that kind of?
There's Quad Shield, which has an added degree of EMI immunity. Fiber has higher bandwidth than RG6, but nothing else that I'm aware of does. So unless you want to go fiber, RG6 is going to be a good way to go. RG6 has the highest bandwidth available, certainly higher than Cat 6.
What about wireless distribution? There are several ways to do that. Of course, there's RF. Then there's the IP wireless Wi-Fi, and then there's this wireless HDMI that no one likes to use that term, but like YHD and so on. Do you have any experience with that?
Well, Wi-Fi has been great for control, and now that they've gotten the N with the 802.11.n, they've got higher bandwidth, so you can go up to 230 feet indoors with N routers, and they have this MIMO, which is a multiple in, multiple out antenna configuration on these access points. So the reliability of Wi-Fi has increased with the advent of the N technology, which is backwards compatible to B and G. There's also Y Gig, which is a Gigabit Alliance. They've just released a spec in May of this year.
Oh, I didn't know about them.
Well, there's it's hard to keep up, so
Sure
that's a 60 gig RF scheme that can transmit up to 7 gigabits of data. You've heard about WiMAX, and that's really more of a portable broadband connectivity scheme for cell phones. And then someone told me about WDHA, and I looked it up, and all I could find was Wisconsin Deer Hunters Association. So I don't really know what that one is. I don't know what that one is yet. I got to do more research. Maybe I've mixed up the letters, or something.
It might be WHDA. That's a possibility. There's this YHD, which I believe is in the 60 gigahertz RF range, which you mentioned a moment ago. But that also is limited only to one room, because that high an RF frequency can't penetrate walls.
Well, that's what I know about microwave, and that is it's a one room, maybe a 2-room solution, unless you've got repeaters in every room. But once you start doing that, then it gets to be kind of expensive. There is the 802.11.s standard, which is a mesh network 802.11 that has some promise as well. So I think there's a lot of hard work being put into improving the throughput and the range on the 802.11 standards. You could pay good money for a high quality a router and switch, and you'll get pretty good results with that.
And I guess RF distribution, just straight ahead RF at 5 gigahertz or 2.5 or whatever it is, or 2.8 maybe, is okay, but not that great, I would assume, because there could be a lot of interference from microwave ovens and cordless phones and all sorts of other stuff.
Yeah, most people who are at 2.4 or 5 gigahertz are working standards, the 802.11 standards.
I'm sorry, would you repeat that? You got a little.
Most people who are developing products in those frequencies, 2.4 gig or 5 gigahertz, are using the 802.11 standards because they've got, error correction and channel hopping and, lots of things built into those standards to make them more robust and reliable. So I'm not really aware of anybody home baking up something alternative in those frequency bands.
Well, I actually wasn't talking about Wi-Fi in that particular case. I know that Wi-Fi also works on those frequencies, but there is also, is there not, essentially analog audio transmission in those same RF bands? For example, wireless surround speakers, I believe, sometimes use analog in those RF bands, or am I completely just totally out of date on that?
Well, no. You're right about that, but I'm more aware of them more like in the 900 megahertz band, as opposed to 2.4 gigahertz band.
I gotcha. Okay, all right. And are those systems still being made? Is that still a useful thing, or is it kind of dinosaur?
There are good. You get, the lower the frequency, the better the penetration through walls are. So 900 megahertz systems, do have good range. I'm really not aware of a whole house multi-channel. Once you want to have multiple channels, then things get a little trickier. So for surround sound in a home theater, these things work real well.
Yeah, okay. What about piggyback systems such as Powerline, MoCA, which is multimedia over coax? Have you done any work with those?
No, I'm aware of both of those technologies. We're not developing products right now that utilize them. Powerline is, the home plug standard, which has been out there for a while. There are a few companies who are selling those kinds of products. It's hard for me to gauge the take rate and acceptability of them, at least in our, custom install channel. So we haven't really ventured down that path at this point in time.
Right. I've always loved the analogy that somebody said once about Powerline, and by that I mean sending signals, mostly digital signals, I think, possibly some analog, high-frequency analog signals down the power lines that are already ubiquitous throughout the house. And somebody likened that to driving a Ferrari on a bumpy dirt road.
I'm going to have to write that one down. That's a good analogy.
I can't claim credit for it. I wish I could because it's beautiful. But you know, you've got this really, really high voltage, high current, and noisy 60 hertz signal, and then you're trying to piggyback onto it this tiny little high frequency signal. That just was a beautiful image to me.
That is funny.
Now I have one more question for you. We're coming towards the end of our time together, and I really appreciate your time. I've gotten a number of questions from readers who have a whole house system that maybe they have a main zone, a home theater kind of a situation, and then some in-ceiling speakers out in the hallway next to the home theater, and they put their system into what's often called party mode, right? So that the same music is being sent out throughout the house. Because they're having a party, right? And so everybody is milling around. And they have this problem, and I don't expect you to solve this problem specifically, but maybe talk about it a little bit, where the audio in the hallway is delayed from the audio in the main zone or some other zone, so that as you're walking from one to the other, you get this kind of, whoa, you know? Have you ever dealt with that kind of a problem before?
Well, I am quite familiar with it. When people attempted to use, you know, the low-cost thin clients for music distribution, they ran into that because of lack of synchronization. But I think what these folks are talking about are when a home theater receiver is broadcasting or playing music, and then you have a different, like a multi-zone amplifier product that is also broadcasting the same source. There's more delay within the receiver because of all the processing in that receiver than there is in a multi-zone amplifier. So if, you know, the easy way to solve that problem is to have a zone in your theater that's background music zone if you want a whole house environment. And that way everything is synced up. Because most of the time it's the difference between the receiver. The receiver is actually a little more delayed than the multi-room. You know, so that's how that happens. It's just a lot more horsepower, a lot more processing power going on within the receiver than in the multi-zone product.
I got you. Okay. Sorry, I did have one other question for you.
Sure.
What is the best audio-video quality one can expect in a whole house system? I can imagine that in what we call the main zone, which would typically be the home theater, you could easily have 1080p video and 5.1 audio. Can you get that high quality into the remote zones, or is that impractical?
No, it's not impractical. 1080p is actually, you know, HDMI 1.1 compliant, which is, you know, like 160 megahertz bandwidth. So you can get that around the house pretty easily. And, you know, unless you've got a screen that's larger than 45-inch for your TV set, I'm not sure you'll see the difference between 720p and 1080p.
Well, that's a point that I argue often about. And while I agree that you probably can't see the difference in terms of detail, you probably can or sometimes might very well be able to see the difference in terms of scaling, because most high-definition sources are 1920 by 1080, whether they're 1080i or 1080p, 1080i from broadcast or satellite, or 1080p from Blu-ray. If you have a 720 or a 768 display, it's going to have to scale it. And you might very well see scaling artifacts. So even if you get a smaller set, I always advocate getting a 1080p if you can to avoid any chance of scaling artifacts.
No argument on that. Seriously, but I do believe that 1080p distribution is easy. Now, if you want the ultimate for the theater, then you want to go with, you know, the latest 3D, you know, kind of sets. LG's got a model that goes for like 15K that I'm aware of. And if you really want, you know, if you want the 4K by 2K, you know, latest and greatest, then you can drop $100,000 on a Sony projector, but, you know, you get a good picture up to 50-foot screen.
Yeah, right.
So, you know, I think that's what they use in movie theaters.
We're certainly going to see a lot of 3D at the CEDIA show this week. And a lot of whole house AV distribution, including from Elan Home Systems.
Absolutely.
So, Bob, I want to thank you very much. Bob Farinelli of Elan Home Systems. You can see his website at elanhomesystems.com. And I want to thank you again, Bob, very much for being on the show.
It's my pleasure, and it was great talking with you. We'll have to catch up at the show and compare some
I look forward to it. Yep, I'll drop by the booth, definitely. My online homes, of course, are ultimateavmag.com and hometheatermag.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott. So like I said, tomorrow I'm off to Atlanta for the CEDIA trade show. And next week I thought it'd be fun, since we will have just gotten back, to get together with some of my journalist colleagues, including Tom Norton, and a few others, to do a roundup of what we saw at CEDIA, because there's going to be a lot to talk about. So I look forward to chatting about that with all of you, and I hope you'll tune in then. And also follow my blogs, of course. I'll be blogging from the show many times per day. So be sure to follow that on ultimateavmag.com and tune in next week for Home Theater Geeks. Until then, geek out!